What if our entire history about Mars is a mistake? For centuries, we believed in a myth we created ourselves. A red dot in the sky always raised questions. People wondered, could it be another living planet? In ancient Rome, it was named after the god of war, Mars. Its color seemed bloody and dangerous. Everything changed with the invention of telescopes. Astronomers saw strange lines on Mars. These lines were mistaken for canals, as if someone had built them. A real Martian fever began. Astronomer Lowell claimed Martians were saving their dying planet. He believed they were pumping water from the poles. The world went crazy over aliens. Newspapers wrote that we were not alone in the universe. But in 1965, the Mariner 4 probe shattered the dream. It sent back images of a dead, lifeless planet. No canals, no cities, just craters, dust, and silence. The illusion collapsed, but a new race had begun. Now we didn't want to meet Martians, we wanted to get there ourselves. In 1971, the USSR launched the first spacecraft into Mars orbit. It was called Mars 2 and became the first orbital mission. Mars 2 attempted to land a capsule but failed. It entered the atmosphere at the wrong angle and crashed. Later, the US responded with Mariner 9. It was the first to successfully orbit and send back images. When Mariner 9 arrived, the whole planet was in a dust storm. It waited weeks for the winds to calm. When the dust cleared, cameras revealed mountains and canyons. Mars was far more complex than anyone thought. In 1976, NASA sent two landers, Viking 1 and Viking 2. They were the first to land softly and search for life. One experiment showed possible signs of metabolism, but the results were inconclusive and remain debated. Since then, searching for life has been the main goal of every mission. Mars was no longer a myth, it became a scientific mystery. In 1997, the first rover arrived, Sojourner. It was tiny but revolutionized the study of the planet. These photos showed Mars up close. Rocks, dust, wheel tracks, everything looked real. In 2004, two new rovers landed on Mars. They were named Spirit and Opportunity. They were meant to last just 90 days, but they worked for years, sending back valuable data. Spirit got stuck in sand and couldn't move, but it kept sending signals to the very end. Opportunity traveled more than 45 kilometers across Mars. It set a record for the longest rover journey. In 2019, a storm disabled the rover. Its last words were, "My battery is low, and it's getting dark." In 2012, Curiosity landed, a full laboratory on wheels. Its landing was the most complex in history. Curiosity found evidence of ancient lakes. Mars once had liquid water. In 2021 came Perseverance, the most advanced rover ever. It's exploring a crater that once held a lake. Along with it arrived Ingenuity, a tiny Mars helicopter. It became the first to fly in another planet's atmosphere. Now, we can not only drive, but fly across Mars. And this is only the beginning of a new chapter in exploration. NASA has long dreamed of returning samples from Mars. Now, that mission is finally in development. Mars rovers have limits. To fully understand its past, we need Martian soil on Earth. Perseverance landed in Jezero Crater, a dry river delta. This site once held water billions of years ago. Sediment layers in the crater may hold ancient life signatures. It's one of the best places to look for biosignatures. Perseverance is collecting core samples and sealing them. These tubes will one day be picked up and sent home. Ingenuity's flights proved controlled flight is possible on Mars. Its technology may be used in future aerial scouts. From above, the helicopter captures stunning terrain images. It scouts paths for the rover to follow. Mars gets its red color from iron oxide in the soil. It's literally rusting over millions of years. Mars has no global magnetic field to block radiation. Future astronauts will need serious protection. The atmosphere on Mars is 100 times thinner than Earth's. It's made mostly of carbon dioxide. Dust storms on Mars can cover the entire planet. They last for weeks and block sunlight. Average surface temperature on Mars is minus 60 degrees Celsius. At night, it can drop to minus 100. Simple weight comparison. Human silhouette on Mars with scale reading 38 kilograms, side by side with Earth at 100 kilograms. Clean scientific layout. Everything must be ultra-realistic. without glitches or unnatural movements. Mars has ice at its poles and beneath the surface. One day, this water may sustain a colony. Mars has two tiny moons, Phobos and Deimos. They look like captured asteroids. Because of signal delay, landers operate on their own. There's no way to control them in real time from Earth. Engineers call it 7 minutes of terror. That's how long descent lasts, with no room for error. Mars is home to the tallest volcano in the solar system, Olympus Mons. It's nearly 3 times the height of Mount Everest. Gales Marineris is the largest canyon in the solar system. It stretches over 4,000 kilometers. Could we one day terraform Mars? Scientists debate the possibility of transforming its climate. Elon Musk wants to build a city on Mars. He believes humans must become multiplanetary. Starship is being designed for interplanetary travel. Its goal: deliver cargo and people to Mars. Mars habitats must protect from radiation and cold. Underground or domed shelters are being studied. Can we grow food on Mars? Scientists are testing crops in simulated Martian soil. NASA and private companies plan to send humans in the 2030s. It could be the most dangerous mission ever attempted. Mars suits must be flexible, pressurized, and dust-proof. Prototypes are already being tested on Earth. A Mars mission may last years, and there's no quick return. Some even call it a one-way trip. Mars challenges our science, our courage, and our imagination. And someday, it might just be our second home. The race to Mars isn't just scientific, it's also political. Nations want to be the first to establish presence on another planet. China and Europe are developing their own Mars missions. The global interest in Mars is growing rapidly. Mars once had a magnetic field like Earth, but it disappeared billions of years ago, leaving the planet exposed. Without that protection, the solar wind stripped away most of the Martian atmosphere. This changed the planet forever. Some scientists believe Mars once looked like earlier, with rivers, lakes, and possibly even oceans. Evidence suggests that water flowed on Mars for millions of years, but the planet slowly lost its ability to retain it. NASA's MAVEN mission studies how Mars lost its atmosphere. It found that solar wind is still eroding the planet today. Today, Mars is a frozen desert, but traces of its wet past are everywhere. NASA's MAVEN mission studies how Mars lost its atmosphere. It found that solar wind is still eroding the planet today. Mars may be lifeless now, but it teaches us about habitability. It could help us find life elsewhere in the universe. Future missions aim to dig deeper into the Martian soil, searching for fossilized microbes or underground water. Subsurface ice could be key to future colonists. It's a vital resource for survival. Mars is a perfect testbed for autonomous robotics. Rovers must think for themselves millions of kilometers away. Artificial intelligence helps navigate the terrain. It avoids obstacles and chooses the best path. If we succeed on Mars, we may go further, to moons like Europa or Titan, even beyond the solar system. Mars inspires a new generation of scientists and explorers. Kids today could walk there tomorrow. Colonizing Mars requires teamwork on a global scale. No single country can do it alone. Building a Mars base is like constructing a space station, but on land. It must be self-sufficient and secure. Mars time is different. A day is 24 hours and 39 minutes. Colonists will need to adjust to the Martian soul. Nuclear energy might provide a backup. Compact reactors are already being tested. Communication with Earth has a delay of up to 22 minutes. Mars missions must rely on autonomy and planning. Psychological health is a major challenge. Crews will face isolation, confinement, and time delay. Virtual reality and robotics may help bridge that gap, letting astronauts feel more connected. Art, music, and culture will travel to Mars too. A new society will need more than just survival. Will we preserve Mars or reshape it for ourselves? Ethical questions will define our choices. Some argue we shouldn't touch Mars at all, that we should protect it as a pristine world. Others believe transforming Mars is our destiny, a way to extend life beyond Earth. Others believe transforming Mars is our destiny, a way to extend life beyond Earth. The first child born on Mars could arrive this century, a human not of Earth, but of two worlds. Mars is far, over 50 million kilometers at its closest, and yet, it feels closer every year. Our robots are already there. Our footprints are next. Mars is silent, cold, and empty, but it calls to us louder than ever. Maybe we go to Mars not because it's easy, but because it's hard. That challenge defines us. From ancient myths to modern rockets, We've chased this red world for centuries, and we're not stopping now. Now we stand at the edge of a new era, the era of becoming interplanetary. Mars forces us to ask, what kind of explorers are we? Brave, curious, or careful? Whatever the answer, Mars is waiting, and we're almost ready. Whatever the answer, Mars is waiting, and we're almost ready. And one day, when someone looks up from the surface of Mars, they'll see Earth as a pale blue dot in the sky.